Namaste friends, welcome you all for the biology session. Let us continue with the chapter Digestion and Absorption. This is Manjunath here from CET Sankalp course. Today we are going to discuss about digestion of fat, right, related to fat digestion and nucleic acid digestion, and how all these nutrients will be absorbed, that is absorption, and related to some disorders in the digestive system, right, and some of the things about vitamins, or you can say vitamins. So let us move on to, in the previous class we discussed about the pancreas, and then along with that some glands, intestinal glands and gastric glands, salivary glands. Related to that we have one question here. That is, we know that pancreas is second largest digestive gland, right? So which is heterocrine. ಯಾಕೆ ಅದನ್ನು heterocrine ಅಂತ ಕರಿತೀವಿ, right? It acts as both exocrine and endocrine gland. Exocrine means generally the secretion will be poured through their ducts, right? It includes ducts, ends will say, and here mainly enzymes will be produced. And endocrine means no ducts, ductless glands. Endocrine means that without ducts, ductless glands, mainly produces hormones. We already discussed that acinar cells, which produces the enzymes, exocrine part, acinar cells, and islets of Langerhans, which produces mainly, which has a different types of cells, that is alpha cells and beta cells and delta cells. Alpha produces the glucagon, beta produces insulin, delta produces somatostatin. So let us take related to this the beta cells. The first option, beta cells, that produces insulin, that is A4. Here we can say in the A and C option we have, but here we don't have. Next, mast cells. So these are the mast cells which mainly produces, generally present associated with the connective tissue. Mast cells which produces the histamine along with that serotonin and heparin and serotonin. So here we can say that the histamine produced by mast cells, that is B3. So B3 we have in the option, C option. Next, let us take C, Paneth cells. Paneth cells which are present associated with the intestinal glands, which produces the lysozymes. And acinar cells, we know that they will going to produce pancreatic enzymes. So answer for that 40th question is C. C is the answer. And many important cells which are there, mainly the Paneth cells which are present in the intestinal glands, that play a major role in the production of certain enzymes, right? And also there are the cells like Argentophin cells. Let me mention that two cells along with that in the intestinal glands, right? In the intestinal glands, right, there are the cells like, as we already mentioned, that epithelial cells produces mucus. Epithelial cells produces, which are present in the intestinal glands, produces mucus. And Paneth cell generally produces digestive enzyme including lysozyme, right? Digestive enzymes, right? Not the pancreatic enzyme, that is a digestive enzymes. And Brunner's gland also we have mentioned there. Along with that, in the intestine we have the intestinal gland. Along with that we have Brunner's gland in the the submucosa of the duodenum. These Brunner's gland which produces mucus, same like goblet cells. So Brunner's gland which produces a mucus, and Argentophin cells produces hormone. Keep it in mind. Intestinal glands, that is epithelial cells, which includes epithelial cells, produces mucus, and Brunner's gland also produces mucus. Punnett cell digestive enzyme, and one more cell which is called as Argentophin cells. Is that Argentophin cells, which produces hormones. Right. ಇದು ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಯಾವ ಎರಡು ಸೆಲ್ಸ್? ಎಪಿಥೀಲಿಯಲ್ ಸೆಲ್ಸ್ ಹಾಗೆ Brunner's gland, which is going to produce same secretion, that is mucus. Right. Next. Second, read the following. What is it? The question, that is statement 1 and 2. Second largest digestive gland in our body is pancreas. So first largest is ಯಾವುದು? ಲಿವರ್, ತುಂಬ ದೊಡ್ಡ ಡೈಜೆಸ್ಟಿವ್ ಗ್ಲ್ಯಾಂಡ್. ಹಾಗೆ ಸ್ಟೇಟ್ಮೆಂಟ್ 2, pancreas function both as exocrine and endocrine gland. So here as it is, what is it, they just mentioned why it is a second largest gland, because it is little smaller than the liver, right? They could have mentioned that, but here they have mentioned what is the functional role of the pancreas. It functions as both exocrine and endocrine. Both statements are correct. Both the statements are correct, but statement 2 is not the correct explanation for statement 1, right? So let us select. If both statement 1 and 2 are correct and the statement 2 is a correct explanation, we could have select A option. No, it is not correct. Both statement 1 and 2 are correct. Statement 2 is not correct explanation. So that is what we can say. B is the answer, right? C, statement 1 is correct, statement 2 is correct. No, both the statements are incorrect. So what is that? Second largest, this is also correct. Function as both. Why it is second largest? It is smaller than the liver, right? All other glands which are there, that is smaller than the pancreas. They should mention like that, right? And one more, in the ileum, additional to this, we can say in the ileum, that is in the small intestine, we can see diffused lymphoid tissue, that is diffused lymphoid tissue, which is called as Peyer's patches. ಇದೊಂದು ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. Peyer's patches, which provide immunity, generally play a role in the providing immunity. Next, let us move on to the next question. During prolonged fasting, in what sequence are the following organic compounds used up? So generally this depends on what is it, how the substrate will going to get digest, right? First the carbohydrate in the body will going to get digest, and later that, because the required energy is very less, right? Where you can say that the for the carbohydrate digestion, the required energy is less, right? The oxidation process less, and next to that the fat, not energy, what is it, which will going to provide, that is energy providing is different, that is a calorific value. Don't get confused with the calorific value and what is that, this one calorific value. We can also say that generally here in fat the calorific value is very high, and next to that we can say that is a protein, and then carbohydrates, right? Whereas for the oxidation process, less energy is required for the digestion of carbohydrates, hence first carbohydrates, and then what is it, the fats, and then what is it, proteins. So finally, right, proteins will be going to digest at the end of the, what is it, after getting digestion of these carbohydrates and fats. ಸೊ ನಾವೇನಾದರೂ ಫಾಸ್ಟಿಂಗ್ ಏನು ಹೇಳ್ತೀವಿ, ಈಗ ಜನರಲಿ ಕೆಲವು ಹಬ್ಬಗಳಲ್ಲಿ ನಾವು ಫಾಸ್ಟಿಂಗ್ ಮಾಡ್ತೀವಿ. ಆಲ್ ದಿ in almost all the caste and creed will going to celebrate the festival, and also which is a good thing, where it will going to give the rest to all those, generally to the vital organs. When we're going to do fasting, these organs will going to take or reduce their metabolic activity, so that they're going to, what is it, proliferate, means we can say that they're going to remove the more toxic substances, right? And they will become, what is it, the very active. So ಇಲ್ಲಿ ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ ಫಸ್ಟ್ ಡೈಜೆಸ್ಟ್ ಆಗುತ್ತೆ, ನೆಕ್ಸ್ಟ್ fat, and then lastly protein. So this is what answer for that is A, right? And let us take just one point related to what is it, the calorific value. So this here we have what is it, the gross calorific value and physical calorific value, right? So just take down that the carbohydrates gross calorific value is something around 4.1, whereas what is it, the physiological calorific value or physical calorific value, which is what is it, the we can say that 4 kilocalories per gram. I think we all know that calorific value, amount of heat liberated from a complete combustion of this substrate, amount of heat liberated when the complete combustion 1 gram of this carbohydrate, what is it, the which will going to liberate that energy, you can say that we will consider as a PCV, right? The total energy is GCV, which is utilized by the what is it, the body, not utilized, which will produce by the body, that is that physiological calorific value. Carbohydrate calorific value is 4, right? Next after that, that is protein. So in case of protein, the calorific value will be 5.65, something around here, what I can say the 4.1, or I can say this is also equal to the in the physiological calorific value 4. And fat, so whenever we're going to consider that the fat, that will be 9.45 is the calorific value, and here we can say that is a 9. So in the decreasing order, if you're going to say that the calorific value, highest fat, and then compared to this is a protein, and then what is that fat more calorific value than protein, and protein more calorific value what is it than carbohydrates. But which is first what is it they get digested, that is carbohydrate, and then later that is fat, lastly that is protein, right? Because for the oxidation process more energy is required, for digestion of protein more energy is required. Now next so this is, you may get increased, what is it, the increase or decrease order, ascending or descending order calorific value. Next question we can take that related to vitamins. Before going to take what is it, the vitamins, let me give some point related to what is it, the fat digestion, right? So fats will be generally in the form of what is it, the glycerols. We can say triglycerol. What is it, triglycerol? That is glycerol with 3 fatty acids, with 3 fatty acids. So that is why we can say most of the fatty acids in this form, right? When what is it, mainly the bile salts, which will going to what is it, the help in the emulsification, the bile salts, that is sodium glycocolate, this triglycerides, in the presence of sodium, was it the glycocolate and sodium taurocolate, these are the bile salts, sodium glycocolate and sodium taurocolate. So when in the presence of this, what is it, bile salts, that will be going to get converted into what is it, the broken down into a smaller pieces. So that is what glycerol with what is it, fatty acids. So and then later once again, if what is it, the lipase, along with that if we are going to act, that is a lipase, that finally it will going to produce, keep it in mind, this we are going to call it as diglyceride. This is triglyceride and this is diglyceride. So these diglycerides, which will be converted by the action of lipase into monoglycerides. So monoglycerides, right, generally which is going to what is it, the with glycerol with 1 fatty acid. That is what we'll say final end product is glycerol and fatty acid. By the action of what, lipase, So here you should keep it in mind that when what is it, the bile juice which reaches the duodenum, that bile juice, right, in the duodenum, along with that the pancreatic juice and then intestinal juice, all those things which will be there in the duodenum, right, and along with that, that is a digested food, which will be called it as chyle, ಸ್ಟಮಕಲ್ಲಿ ಖೈಮ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸ್ಟಮಕಲ್ಲಿ ಅಸಿಡಿಕ್ ಫುಡ್ ಜೊತೆಗಿರುತ್ತೆ, ಗ್ಯಾಸ್ಟ್ರಿಕ್ ಜ್ಯೂಸ್ ಆ್ಯಂಡ್ ಅಸಿಡಿಕ್ ಫುಡ್, which will be called it as chyme, right, in the buccal cavity, which will be called it as bolus ಅಂತ ಕರಿತೀವಿ. So in the duodenum, I can say that in the small intestine, that is called as chyle, which is digested food, completely digested food. So this is the end products of after fat completely when it digested. So fatty acids will be there. It won't change like how carbohydrates and the proteins will going to change into a different form, right? We can say polysaccharides into monomers. Here fatty acids will be there, hence its nature won't change. So this is, you have to keep it in mind. And here one more point let me mention here, that these fat globules which will be produced with the help of bile juice, right, that which will going to convert it, or fat globules will be covered by protein coat, right. So these smaller the fat globules which will going to covered by protein coat, just assume this is a protein coat, which will be called it as chylomicron. This can the penetrate through the epithelium of the intestine into the lacteals. So this glycerol and fatty acids which enters the intestinal epithelium in the form of the chylomicron, that is protein coated fat globules, right. That is, we can say that the phospholipids, cholesterol, right, along with that this the glycerol and fatty acids, right. So next, vitamins, which is very very important actually. In the lower classes many a times we discuss, just I'll give some points which is the related to the vitamins. There are two types of vitamins, as we all know that. What are those? Fat soluble vitamins, fat soluble and fat insoluble vitamins. Fat insoluble vitamins. So fat soluble, A, D, E, K, and the fat insoluble, that is vitamin the B and vitamin C, right, B complexes, which includes B1, B2, B3 and then B12. So just I will give their name, right. Just A, which will be called it as, we all know that A, retinol. The chemical name is retinol. Their deficiency causes what? Night blindness. And one more, xerophthalmia, right, night blindness one. And xerophthalmia means the inflammation in the eye, or you can say that whenever this the night blindness which used to affect, that is retinol production won't be there, or which when it will be scarce supply, or you can say that the less supply, that leads to the inflammation and drying of eyeball, which is called as xerophthalmia. Xerophthalmia. Next, vitamin A, retinol, and then same like that vitamin D, which is called as calciferol. Vitamin D, calciferol, mainly causes rickets in children, right, and osteomalacia in adults. Both are related to the bone, the defects. We can say that the osteomalacia, where you can say that muscle and bone weakness will be there, that is in children, which is called as the rickets. In adults is called as osteomalacia. And vitamin E called as tocopherol. Here only we have vitamin E, the tocopherol. Tocopherol, we know that generally its scarcity leads to sterility, right? So we can say that the anti-sterility hormone, right? It helps in uh, helps in maintaining fertility, or you can say that reproductive to correct the reproductive failure. If scarcity is there, there will be reproductive failure. Reproductive failure. So what you should keep in mind, it acts as a anti-sterility hormone. Anti-sterility, sorry, not hormone, that is vitamin. So next, and then last one, EK, ADEK. So whenever we're going to mention that the K, phylloquinone, right? Phylloquinone is the one which will be very much required for the vitamin K, which is required for clotting for coagulation purpose. If vitamin K deficiency, there will be prolonged or long-term bleeding will be there, right? It's very difficult to stop bleeding. So these are the things which are related to fat soluble, right? And vitamin B1 beriberi, that is which is called as thiamine, B2 riboflavin, right? B1, which we can say here, that is vitamin B1, that is thiamine deficiency leads to beriberi. So let me take next question here. So beriberi, which is mainly caused by vitamin B1. Keep it in mind, these are fat insoluble, right? They won't dissolve in fat. So that is what we should provide. Continuously, or you can say that through the diet. But sometimes fat, the soluble, which will be there stored in the fat soluble along with the bile juice, that is, it will be stored in the liver, right? Fat insoluble, vitamin B1, chemical name, or thiamine, right? Thiamine, which is a deficiency leads to beriberi. So mainly here you have to keep it in mind that beriberi means there will be a weight loss, weakness, and swelling of body tissues, impaired sensory perception, right? Beriberi, weakness, sensory, the impairedness, and along with that the weight loss. And then B2, vitamin B2, riboflavin, which generally causes cataracts. And next one more, that is niacin, that is B3, important. These are that is niacin, which causes pellagra. So in case of the vitamin B3 deficiency, that is mainly in the pellagra, right? Cramps and nausea, mental confusion will be there. Cramps, nausea, and mental confusion will be there. So with this, we can move on to, and we all know that vitamin B12, I think we have discussed that pernicious anemia deficiency causes pernicious anemia. Deficiency causes pernicious anemia, means no production of RBC. Vitamin B12, cobalamin. Let us take this. So beriberi is because of B1. Beriberi is because of the B1. And that is scurvy, that is because of vitamin C. Vitamin C deficiency, which leads to scurvy. As we all know that scurvy, bleeding in gums, right? And along with that, here we can also say that the no collagen synthesis, scurvy, and this C is very much required for collagen synthesis. If there is a deficiency, no collagen synthesis takes place. Hence, there will be the bleeding, right? C, what is the scientific name in almost all the citrus fruit? Ascorbic acid. So D, vitamin D, vitamin D mainly causes, in case of that vitamin D, we'll say rickets. But here rickets because of deficiency of vitamin D. Scurvy because of B1, C, D. So what is the answer? Right, that is B is the answer. Beriberi by B1, scurvy, vitamin C, rickets, vitamin D. Rickets, vitamin D. Next, lacteals take part in the, as we all know that in the previous class we discussed, that is the finger-like projections. There will be a lacteals which will going to absorb fats in the form of, what is it, chylomicrons. Digestion of milk, no, that is generally the renin, and absorption of fat in the form of chylomicron. Digestion of lactic acid, no, that is lactic acid, that is sucrose. Mainly we can say that the sucrose is the blood sugar, sorry, milk sugar, which will be converted into sucrose, which will be converted into lactic acid, and then that will be converted into, what is it, the curd. Right, absorption of fat is the answer. Lacteals take part in the absorption of fat. So B is the answer. So next question, normal human being requires. So what is that here? We'll say that is PCV and GCV, gross calorific value, and what is it, the physiological calorific value, how much the energy will be released by those substrate. Carbohydrates released, what is that, the per gram it will release 4 kilocalorie. 4 kilocalorie. Same like that, protein release, that is also approximately 4 to 5 kilocalorie. And fat which is going to release more calorific value, fat with, what is it, the 9 kilocalorie per gram will be released. But per day, how much calories required to a normal human being? See, whenever we're going to, what is it, the work, strenuous work will be there, that is, we'll say routine, that is which will be there, routine metabolic rate, routine metabolic rate. So in this, generally more calories required, and there will be a basal metabolic rate, RMR and BMR. Basal metabolic rate, when generally we will be at normal condition, at rest. Basal, what is that, metabolic rate. So for basal metabolic rate, commonly required something 1600 to 1800 kilocalorie, that is enough. 1800 to 1600 to 1800 kilocalories required per day. This is per day for normal, when person at rest, for normal metabolic, or you can say that during sleep, right, at sleep, or you can say that at rest, required energy is, what is that, required calorific, what is it, the calories is 1600 kilocalories to 1800 kilocalories per day. Right, when you are going to perform your work, in college ಹೋಗ್ತೀವಿ, we are going to play a game, so on that time it is required, what is it, for adult man which is required more and compare with the female. Generally adult man requires 2800 kilocalories, and in case of, what is it, the woman, right, required something around 2200 to 2000 kilocalorie. This all for both per day, we can say. So what is that? Generally 46, the answer is, that is 2500 for a normal man, at least approximately, right, an average required is, what is that, 2500 kilocalories. 2500 kilocalories. Next, let us move on to the next question. The hydrolysis of, what is it, the lipid yields. As we already discussed that hydrolysis of lipids, which will going to yield. Here the 46th question, the answer is A, right? So next, hydrolysis of lipids in the presence of lipase, what happens? Lipase finally will going to produce what we have mentioned, right, by the action of, that is the triglycerides, fat, most commonly in the form of triglycerides, right, which will be produced finally glycerol and fatty acid. Glycerol and fatty acid. So that is what you have to keep in mind. So answer for that is B. So when fatty acids which will be absorbed mainly in the form of chylomicron. First it will be converted into micelle, and then into the, what is it, the chylomicron. And whereas the nucleic acid digestion, let us take that, the nucleic acid digestion later in the next question, right? Here, that is, we mentioned this digestion of protein, fat, carbohydrate completed in, see, absorption completes in ileum. Absorption, major seat of absorption is ileum, right? So last part of the, what is that, small intestine. Whereas the digestion, by pouring all those, the enzymes from the pancreatic juice, intestinal juice, and bile juice, there won't be any enzyme, but there will be bile salts. So all these which will be going to help in the digestion of, what is it, these substrated protein, fats, and carbohydrates, that is in the duodenum. So answer for that 48 question is, what is that, duodenum. So next, emulsification of fat by bile juice producers, right? Here, let us take this first, triglycerides, which will be bigger molecules, which will be converted into triglycerol, which will be converted into, what is it, small fat globules, and then in turn it will be converted into, what is that, triglycerides, when bile salts, which are going to cover around the fat globules, and they're going to break down. When they're going to break down into that, there will be generally glycerol. Here there will be glycerol and 3 fatty acids. When the bile salts will going to help in the emulsification before, what is it, the activated form of lipase, which will going to act on next, that is the glycerol and 2 fatty acids. So this form will be produced by the action, that is in the process of emulsification of fat by bile juice. Bile juice also activates lipase. So that is a major role. So here for the 9th question, that is a 2 fatty acids, 1 glyceride, which will be produced because of the emulsification, not because of the lipase. Lipase, that is glycerol and fatty acid end product. Because of the bile, what is it, the salt which will going to involved in the emulsification, glycerol and 2 fatty acids. Clear is that? Next, water is largely absorbed. So most of the water which will be absorbed in, what is it, the small intestine, right? Almost all the nutrients and complete water will be absorbed in the small intestine. Whereas in the esophagus, there won't be any absorption and digestion. And in the stomach, there will be little portion of alcohol which will be going to get absorbed. So whereas the major, that is, they will say the principal site of, what is it, the absorption, principal site of absorption is, what is it, mainly ileum. Principal site of digestion, which is principal site, or I can say principal organ of absorption. This you may get this question, right? Principal organ of absorption. Organ of absorption is, what is that, mainly ileum. Where complete absorption takes place, right? We can say, and digestion is going to complete in the duodenum, but all those things which takes place in the small intestine only, that is, digestion completes in the duodenum, absorption completes in the ileum. So next, and in the mouth some drugs will be absorbed, and in the stomach water and some of the little amount of alcohol which will be going to absorb, right? And in the large intestine, we know that only electrolytes and little water, not the large water, only small quantity of water, small amount of water and some electrolytes which will be absorbed in the large intestine. Next, let us move on to the next question. Gastric juice does not contain. So gastric juice does not contain. So as we have mentioned that in the salivary amylase, right, generally we can say that the enzyme amylase which acts on carbohydrates, which helps in what is it, the carbohydrate digestion. Same like that in the gastric juice there will be what is it, the proteases which acts on proteins, but no what is that, the amylase. There won't be amylase. No carbohydrate digestion takes place in this what is that, stomach. In stomach, but there will be little amount of gastric juice. Sorry, gastric lipase. Right, there will be gastric lipase, very little, right, very small quantity of negligible amount of what is it, the small amount of lipase will be there, that is a gastric lipase, but there is no gastric amylase which helps in carbohydrates, hence no carbohydrate digestion. No carbohydrate digestion takes place in the stomach because there is no what is that, amylase. There will be protease enzyme, there will be renin and gastric lipase, no amylase. Hence the answer for this is amylase is absent in the gastric juice. And the next question, hydrolysis followed by what is it, the generally with the help of what is it, the enzyme only produces glucose. I mentioned that generally what is it, the salivary amylase which produces maltose and then isomaltose, it won't produce directly glucose, correct, right? Hence we cannot select that answer, adu answer agalla. So hage, and then the sucrase, what is that, that is sucrose and fructose kodutte alva, that will going to hydrolyze this what is it, mainly this sucrose that will be converted into what is that, glucose and fructose, not both what is it, the monomers won't be glucose. Whereas maltase which will be acted on what is it, the maltose, and it is then maltase acts on maltose that produces only glucose. So answer for that. Whereas in the lactase we can say, right, lactase in the which acts on lactose which produces glucose and galactose. Hence the answer for that is what is that, maltase, only maltase. And along with we can also mention there isomaltase, but they are not given in the option. Isomaltase, right, isomaltase which acts on isomaltose that will going to produce what is that, glucose and glucose, but they are not given in the option. We can select what is that, the maltase is the enzyme which produces only glucose. Next, that is what the glycosidic bond, that is based on the position when what is it, the mainly by the action of amylase, that is on the carbohydrates, and the amylase acts on carbohydrates, that will going to break the bond which is called as glycosidic bond. The monomers, right, they can say that these monomers glucose which will be there, they are what is it, the attached by a bond called as glycosidic bond. So this what is it, when the starch is digested by the amylase, this glycosidic bond will going to broken down and produces monomers, what we have discussed in the previous slide, that is they are the monomers, glucose, fructose, glucose, galactose, glucose, like that, which will be produced. Next, let us take some what is it, the hormones, right? Some hormones which will be produced by the duodenum, some which will be produced by the stomach, and also from the what is it, the intestinal part, that is we can say the other part of the intestine. So what exactly the thing you have to keep it in mind here, these hormones which will be produced, just I will mention, from the what is it, the stomach, the gastrin will be produced. Gastrin hormone produced by stomach. Mainly that is a pyloric region. Pyloric region. And there are the three hormones is very very important. So let me take that in a, first I will explain that in a different slide. Here as there is no space, so I'm going to take that in this, make a list of this. Here we're going to get such questions sometime. One is, that is the, from the duodenum enterogastron will be produced. One is enterogastron. Stomach produces gastrin, that which helps in the secretion of gastric juice. And whereas enterogastron produced by, what is it, the duodenum, produced by duodenum, which mainly helps in the enterogastron, which helps in, what is that, mainly the production of gastrin, which helps in the production of gastric juice, right? Gastrin, which helps in the production of gastric juice. Against that gastrin, this will going to act, which inhibits, so that it will going to reduce the secretion of, inhibits the secretion of gastric juice. Enterogastron inhibits, what is that, gastric juice secretion. Gastric juice secretion, right? So this, what is it, the enterogastron, which act against the, what is that, gastrin, and inhibits the production of gastric juice. And one more we can say, that is secretin, right? Next question what we are discussing, the secretin is the hormone produced by, what is it, the duodenum. It is the first hormone which is discovered, that is produced by the duodenum, mainly acts on, keep it in mind, this is a target organs, or target on three parts. One is, it targets the pancreas for the release of pancreatic juice. Make a list of this. Pancreas to release pancreatic juice, and liver for the, mainly for the release of bile, right? And along with that, there will be, what is it, the some bile salts and other things which will be produced, but that will be by the cholecystokine, right? Next, liver, pancreas, liver, and it also acts on stomach. Secretin acts on stomach, where it inhibits the complete gastrin inhibits, what is that, the gastrin production, inhibits the gastrin hormone production itself. Here, what is it, the enterogastron only inhibits the secretion of gastric juice, reduces the gastric juice, but here it inhibits the hormone itself, that is secretin. So one more here, these three things you have to keep it in mind, that is secretin acts on pancreas, for the release of pancreatic juice, right? Right? And also sodium carbonate, where you can say that whenever it will going to, what is it, the helps, right? Mainly here you have to keep it in mind, target on the pancreas, where the pancreatic, the glands which will be there mainly to release the sodium bicarbonate, or you can say that the sodium carbonate into the pancreatic juice. So this is the one major role, role, not rule, that is mainly to decrease the acidity, right? That is to convert the acidic food into alkaline. Then only all the enzymes can gets activate. ಇಲ್ಲಾಂದ್ರೆ ಆಗಲ್ಲ. ಯಾವಾಗ ಇದು ಪ್ಯಾಂಕ್ರಿಯಾಟಿಕ್ ಜ್ಯೂಸ್ ವಿತ್ ವಾಟ್ ಇಸ್ ಇಟ್ ದಿ ಸೋಡಿಯಂ ಬೈಕಾರ್ಬೊನೇಟ್ ಡಿಯೋಡನಮ್ಗೆ ಎಂಟ್ರಿ ಆಗುತ್ತೆ, ಅಲ್ಲಿ ಇಟ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ವರ್ಟ್ ದಟ್ ಅಸಿಡಿಕ್ ಫುಡ್ ಇಂಟು ಆಲ್ಕಲೈನ್. ಸೊ ದಿಸ್ ಆರ್ ದಿ ಥಿಂಗ್ಸ್ ಯು ಹ್ಯಾವ್ ಟು ಕೀಪ್ ಇಟ್ ಇನ್ ಮೈಂಡ್. What is the related to, what is this secretin? Secretin stimulates the secretion of pancreas, inhibits the acidic secretion. Yes, it acts on stomach also, we can consider, and stimulates the gallbladder. So whenever we're going to say that which helps in the release of, what is it, the helps in the release of bile, definitely it will going to, what is that, they stimulates, mainly it stimulates the contraction, but here stimulates the enzyme secretion, that is by cholecystokinin, not secretin. See, enzyme secretion by pancreas, that is not the role of secretin. Secretin, which is mainly helps in the secretion of pancreatic juice, that to sodium bicarbonate, sodium bicarbonate into the pancreatic juice, secretion of sodium bicarbonate into the pancreatic juice help ಮಾಡುತ್ತೆ, not the enzyme. Enzyme secretion into the pancreatic juice done by cholecystokinin, that is cholecystokinin, that is also hormone released by duodenum. This is the hormone released by duodenum. Cholecystokinin, cholecystokinin, which what is that? They stimulates the contraction of gallbladder, stimulates the contraction of what is that? Gallbladder, stimulates the contraction of gallbladder, and along with that it helps in the release of pancreatic juice also. It helps in the release of pancreatic juice with enzyme. Mainly enzyme will be released into the pancreatic juice by the action of cholecystokinin. And one more, the important thing here we should keep it in mind, that whenever this cholecystokinin what is it, they gets activated, it is going to release, the stimulus is fat should enter, because bile will going to pour, right? When fat enters the duodenum, when fat, food with a fat enters the duodenum, that acts as stimulus for the release of cholecystokinin. So what is the stimulus for the release of secretin? When food enters, that is when chyme enters the duodenum. When chyme enters duodenum, then secretin will be produced. When chyme enters the duodenum, then secretin will be produced. So here stimulates the enzyme, that is cholecystokinin, inhibits the acid secretion, in the stomach, that is enterogastron, right? And stimulates the gallbladder, that is also what is it, we can say cholecystokinin. Stimulates bicarbonate secretion by pancreas, inhibits the acid secretion in stomach, and stimulates the bicarbonate secretion by liver. No, it is not bicarbonate, that is bile juice secretion. Stimulates the acid secretion in stomach. No, generally whenever we're going to say that the secretion, you have to keep it in mind, it won't stimulate the secretion of acid, it inhibits, right? So major function of the secretin inhibits the gastrin, that is you should keep it in mind. When it will going to inhibit the gastrin, finally it will going to, what is that? So this here we're going to take this, we can't say stimulates the acid, inhibits, and potentiates the action of cholecystokinin. No. Inhibits the intestinal movement. No. Next, when you come to this, the inhibits the intestinal movement, right? So whenever we're going to say this will be accelerated by villikinin, right? Accelerated by villikinin, but it is inhibited by the intestinal movement, which will be inhibited by what is it? These the other hormones, right? Which are related to the digestion. So this is also wrong. Stimulates gallbladder, correct? Inhibits the, what is that? Inhibits the, mainly stimulates gallbladder means to release bile juice. Inhibits the acid secretion, correct? Stimulates the bicarbonate secretion by pancreas. So answer for that is D, right? So next, which of the following, what is it, the order the process of digestion proceeds? We know that first ingestion, digestion, absorption, assimilation, and then digestion, and then digestion. So these are the things what is it, which is going to take place in the holozoic nutrition, step by step process. Next, read the statement. Athletes, that is laborers, will going to do heavy work. Mountaineers, mountain dwellers means those who are going to live in the mountain. Mountaineers means those will go for from lower altitude to the higher altitude. Should live on high carbohydrate diet. Yes, it is correct. Why? Because there will be less availability of the oxygen in the high altitude, less oxygen supply, and then for energy for the oxidation will be less. Energy will be less for the oxidation purpose. So hence first carbohydrate, they should take more the diet with more carbohydrate. Correct. Carbohydrate needs less respiratory oxygen for oxidation. That is also correct. Both the statement 1 and 2 are correct. And the 2 is the correct explanation. 2 is the correct explanation for the 1. That is answer is A. So 56th question answer is A. And next to that we can take there the fat, and then protein. That is what first carbohydrates will going to get digest, and then fat, and then finally lastly protein. Next, which category compounds is most concentrated energy source? ಯಾವುದು ಜಾಸ್ತಿ ಎನರ್ಜಿ ಸೋರ್ಸ್ ಕೊಡೋದು? ನಾವು ಅಲ್ಲಿ ಕ್ಯಾಲೋರಿಫಿಕ್ ವ್ಯಾಲ್ಯೂ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ. ಸೊ ವೆನೆವರ್ ವಿ ಗೋಯಿಂಗ್ ಟು ಸಿ ದಿಸ್ ಜನರಲಿ, ರೈಟ್, ಫ್ಯಾಟ್ಸ್ which will be with more concentrated food, correct, right? Whereas a carbohydrates 4 kilocalorie per gram, and even protein approximately same, that is the 4 to 5, whereas a fat which gives the calorific value that is 9. So that is answer for that is lipids. 57A. Next, major utility of breaking of food. What is it? Breaking of food process is called as mastication. So mastication process mainly helps to the convert the smaller the larger food particles into smaller, so that surface area increases. So that if more smaller, the surface area of food will be increases, so that it will be easily eaten. We can have it easily. So answer for that is B. To increase the surface area of the food eaten up, not to reduce, wrong. To make food soluble, that is also wrong. And to enjoy the taste, nowadays people are having food for that only, right? Taste, not to have a nutritional the food. So next, the contraction of gallbladder is due to, that is where we have mentioned contraction. See, that is what this stimulates cholecystokinin, which stimulates the contraction of gallbladder. Stimulates the contraction of gallbladder. Whereas secretin, which stimulates the liver to produce bile juice. Don't get confused with this. To produce bile juice, right? Bile juice produced by the liver, which will be stored in the gallbladder. Hence, that is what release. That is the production of the bile juice in the liver will be increased by the action of secretin and gastrin, which mainly helps in the the production of gastric juice produced by stomach, right? So this will be stimulated when food enters the stomach. Gastrin will be produced when food enters stomach, that is bolus, right? Enterogastron, which will going to inhibits the gastric juice production. So contraction of gallbladder mainly by cholecystokinin, right? Cholecystokinin. Next, which of the following is incorrectly represented? Today question solve ಮಾಡಬೇಕಾದ್ರೆ whether they are going to ask whether they have asked incorrect, to select incorrect statement or correct statement mark ಮಾಡಬೇಕಾದ್ರೆ first ಇದನ್ನ ಅಂಡರ್ಲೈನ್ ಮಾಡಿ. Incorrect. Right now, protein in the presence of trypsin, chymotrypsin, carboxypeptidase converted into dipeptides, or we can also say that the peptones and proteoses because of the action of trypsin, and then finally into dipeptides with the help of carboxypeptidase and chymotrypsin. Right, that is we can consider. Next, in the intestinal glands, this is very very important. Intestinal glands, where the intestinal juice will be produced, there we can see nucleotidases, nucleotidases, nucleotidase and nucleosidase. But whereas nuclease will be produced present seen in pancreatic juice. This is very very important. Nuclease, which acts on nucleic acids and convert that into nucleotides, and on that nucleotides these will going to act. Nucleotidase will going to act, convert that into nucleoside, and on that nucleoside nucleosidase will going to act. So what is it here? Nuclease, to convert the nucleic acids into nucleotide. What is that? Nuclease is required, not what is it? Nucleotide. Nucleotidase acts on nucleotides. Now here on this nucleotidase will going to act and convert that into nucleoside. On this, what is that? Nucleosidase, right? Nucleosidase will going to act and that will be converted into what is it? The base pair. Next. So this is the wrong one. Incorrectly, let us take next option. Fat lipases convert into di or monoglycerides. So we can say that this is correct. And even A option is also correct. Starch salivary amylase convert that into maltose. That is also correct. So answer incorrectly, what is it? The represented is B option. Next, stool of a person, that is in this case we'll take that is a disorder related to that. The stool of a person whitish gray colored due to malfunction of which of the following? Generally, so very important thing you have to keep in mind that in case of disorders, right, that is where the liver is affected, bile pigments won't be eliminated. That is, if accumulation of bile pigment, ಯಾಕೆ ಅಕ್ಯುಮುಲೇಷನ್ ಆಗುತ್ತೆ? ಬೈಲ್ ಪಿಗ್ಮೆಂಟ್ಸ್ ಎಲಿಮಿನೇಟ್ ಆಗಬೇಕು ಅಂದರೆ ಬೈಲ್ ಜ್ಯೂಸ್ ಬೇಕು, ರೈಟ್? ಸೊ ಈ ಬೈಲ್ ಜ್ಯೂಸ್ ಇಲ್ಲ ಅಂದರೆ ದಿಸ್ ಕಾಂಟ್ ಬಿ ಏಬಲ್ ಟು ಎಕ್ಸ್ಕ್ರೀಟ್ ಔಟ್. ಸೊ ಏನಾಗುತ್ತೆ, ಬಾಡಿನಲ್ಲಿ ದೀಸ್ ಬೈಲ್ ಪಿಗ್ಮೆಂಟ್ಸ್ ವಿಲ್ ಗೋಯಿಂಗ್ ಟು ಅಕ್ಯುಮುಲೇಟ್, ಕನ್ವರ್ಟ್ ವಾಟ್ ಇಸ್ ದಿ ಬಾಡಿ, generally the color of the body into yellowish. So jaundice, where skin, eyes, nails becomes yellowish due to accumulation of bile pigments. Why? Because there won't be bile juice production because liver is affected. That condition which will be the appearance of yellowish eyes, and then what is it, mainly the skin becomes what is it, this yellowish, and eyes, and along with that nails. So this is the symptom of what is that, liver damage. So whenever we are going to say that condition is called as jaundice, that is jaundice. So whitish gray color. Why? Because, sir, why whitish color? Generally stool will be yellow in color. Generally stool which will be what is that, yellow in color. Stool will be yellow in color. Why? Because of these pigments which will be eliminated with the help of bile juice. Now there is no pigment, right? Then because of that, what is that, the stool which will be, because when the damaged condition of the liver, stool becomes whitish gray. Clear ಇದೆ? Whitish gray ಅಂದರೆ pigments eliminate ಆಗ್ತಿಲ್ಲ ಅಂತ through stool. For what is the yellow color characteristic feature of the stool, the very much responsible for that is presence of these pigments, mainly biliverdin and bilirubin. So these which will be responsible for that yellow color, if these were absent, that stool becomes whitish gray, that is liver is damaged. Next, Which of the following correct regarding jaundice? Skin turns yellow, correct. Eye turns yellow, liver gets affected. So all of these corrected in this. What is the question? Next, ejection of stomach contents through mouth is called as. What is that? Generally, vomiting. We'll say that it is a when infectious, what is it, the food, or you can say that the poisonous food, anywhere which will be going to taken into the, what is it, the body, that is which enters into the gut. If it is not able to digest, or it will going to create some, what is it, the irritation, right, that will going to send a message. As soon as food enters, that will send a message, that is a reflex action will going to play a role. Reflex action will going to play a role controlled along with the, what is it, vomiting center, along with the, what is it, vomiting center. So vomiting center is medulla oblongata. So reflex action, that is the controlled by medulla oblongata. Suddenly, somebody vomit ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಸ್ಲೋ ವಾಮಿಟ್ ಮಾಡಲ್ಲ, that suddenly the food content, right, ejection of stomach content through mouth is called as vomiting. So ಇಲ್ಲಿ ನಾವು ಜನರಲ್ಲಾಗಿ ಬಿಫೋರ್ ವಾಮಿಟಿಂಗ್ ಏನಾಗುತ್ತೆ, ನಾಸಿಯಾ, ಒಂಥರ ಸಿಕ್ನೆಸ್ ಆಗುತ್ತೆ. What is the bitterness, or you can say that slightly the saliva which will be released more, and then sometime it is like, what is it, the before the vomiting, that is like tale suttanga agodu, right. So these things will going to takes place. So in digestion, we know that the food is not digested properly, right. Food is not digested properly due to, what is it, the causes may be anxiety, food poisoning, overeating, tumba tinbirtive, spicy food. So indigestion is because of anxiety, food poisoning, and then overeating and more spicy food, that is food which is completely spicy, right. Then we're going to consider it as, what is it, because of the reason, or you can say that the causes for indigestion. So diarrhea, that is abnormal, or you can say that the abnormal or uncontrolled bowel movement. Bowel movement frequently will be there. Constipation, irregular bowel movement. Normal iralla, that is not abnormal but irregular bowel movement. So this is, what is it, the things you have to keep it in mind in case of disorders. Next, so which of the following statement is incorrect? Fecal accumulation in rectum initiates the neural reflex causing an urge for removal. Fecal accumulation in, what is it, the rectum initiates a neural reflex. No, generally when it will going to eliminate, right, once it gets filled, it initiates, right, urge, right. So generally there will be, we can say, rectum temporarily which will going to store. Yes, we can say that the fecal accumulation in rectum initiates a neural reflex, right. That will going to, what is it, the mainly, what is it, it makes the sphincter, right, the anal sphincter to, what is it, relax, right. So now in this case, irregular bowel movement causes constipation, that is also correct. That is abnormal bowel movement, diarrhea. Irregular, what is it, the not frequently, that is diarrhea is abnormal, frequent, continuous bowel movement, that may leads to dehydration, right. More, what is it, the liquid food will be discharged in case of diarrhea, but whereas here it gets solidifies in the rectum, and that will be accumulates in the rectum, so that it's very difficult to, what is it, they pass out. In diarrhea, absorption of food is increased. No, as there is a, what is it, the increased, what is it, the liquidity, the condition is increased liquidity of the food, right. more the food will be eliminated. So no absorption, no proper absorption in case of generally diarrhea. That reduces the absorption because of the increased the liquidity reduces the absorption, but it won't increases it. Absorption of food is increased. No, this is wrong. This that reduces the absorption. Next, anxiety and eating spicy food together in an otherwise normal human may lead to, that is already we discussed that, right? In this case what happens, that is food won't get digested properly. That condition is called as indigestion. Jaundice, liver damage, diarrhea, the abnormal bowel movement frequently, vomiting, sudden reflex action, right? Where from through the mouth, stomach food will be food, which will be ejected out. Stomach food will be ejected out. And emaciation of body means thinning. The volume of the body decreases, thinning of limbs, skin becoming dry, thin, wrinkled, impairment of growth, development, and mainly the brain and mental the faculties in infants less than a year in the age occurs. Means this is mainly here we can say that there are two the protein energy malnutrition. One is kwashiorkor, other one is marasmus. So whenever we're going to the think about this, generally the kwashiorkor where the body, this volume of the body decreases, but there will be the other diets will be there here. Only protein deficiency in case of kwashiorkor, only protein deficiency, right? There will be the other thing we can say, body which won't completely become thin, but in case of marasmus it completely becomes the thin. Here both the protein and other calories deficiency will be there. Other calories deficiency completely nil, right? But here only protein. So that is why in case of marasmus we can see this condition where completely, that too in the less than year, more than 1 year, that is 1.5 year. ಈಗ ಅಮ್ಮ ಹಾಲು ಕುಡಿಸೋದು ಬಿಡ್ತಾಳೆ, ಅಲ್ಲಿ ಜನರಲಿ ಓನ್ಲಿ ಪ್ರೋಟೀನ್ ಡಿಫಿಷಿಯನ್ಸಿ ಇರುತ್ತೆ, ಬಟ್ ಬೇಬಿ ಯೂಸ್ ಟು ಹ್ಯಾವ್ ಅದರ್ ಫುಡ್. Only protein deficiency kwashiorkor, right? That is after 1.5 year or above 1 year. Within 1 year, less than the 1 year infant will be affected from the marasmus. These are the symptoms. Kwashiorkor occurs due to, that is already we discussed, only protein deficiency. Marasmus, both protein and calories. Both proteins and calories leads to the protein energy malnutrition called as marasmus. Less than 1 year the infants will going to affect from this mainly, whereas only protein deficiency, that is kwashiorkor. So answer for that is deficiency of protein, right? Next, so some questions are there, 3 questions. So these are for your homework question. So thank you. Let us this start in the next video. Let us start with the next chapter, right? Thank you.